for the part 2 of the applications of laws of motion, so today we'll discuss here tension force, and then we'll be solving problems involving tension. First, what is tensional force? Tensional force is the force that is transmitted through strings, ropes, or cables, of course, if it is pulled tight. Say, for example, something is hanged from the ceiling, and then there's this rope, okay, attached to the object, then tensional force is present in that string, okay? And if you're hanging something, if you will look around you and you see that something is hanged by a rope or a string, then there is a tensional force. Let's have this sample problem. Determine the amount of tension force present on the strings if a 5.6 kilogram box is being hanged on both ends, making an angle of 30 degrees on one end and 45 degrees on another, both from the horizontal line. So here's the problem. Okay, so first, of course, we have to illustrate the problem so that you'll be guided. Okay, so see, for example, we have this one. So here's the ceiling. Okay, so that is the ceiling. Usually if you'll see this, so this represents a board or a ceiling. Okay, and then let's have here, okay, this one, which makes 30 degrees, so a little off, and then another string which makes 45 degrees, and then we have here the box. Okay, so here, so let's label this one. So this is the 30 degrees, okay, on one end, and then we have here 45 degrees on another end. Okay, and of course this object has its mass equal to 5.6 kilogram. Okay, so let's draw the free body diagram of this. So let's use different colored pen. So here we have this tensional force, and we also have this tensional force, of course, here. And of course, there's this object, so there is weight. Okay, so let's name this as tension 2, and then we have here the tension 1. Okay, so by drawing the free body diagram, we can have here, of course, that tension 1. Okay, this one is your T1, and then let's have here your tension 2, which is a bit bigger in angle. Okay, so that this is that, and we have here the weight. Okay, so the weight is directed downward or towards the center of the earth, of course. So this is the weight, and this is T2. T2. Okay, so here's your free body diagram. So let's have this one. Okay, as you can see, so yeah. And because these lines or angles, of course, we can set these angles on this position here. Okay, so this is also 30 degrees, and this is your 45 degrees. Remember in mathematics that if we have here this line, say for example, parallel lines cut by a transversal, okay, so if this is your 45 degrees, this one will also make 45 degrees. Okay, alternate interior angles. That's why this 45 degrees can also be found here. That's the same. Okay, so that's the concept. And then, yeah, because we have here these angles, so if we will form the triangle here, yeah, we form a right triangle, right? So we can now write the components of this vector. We will have here our T2. Let's have first the T1. So this is our T1. So this is your T1 sub X. And then this is your T1 sub Y, the Y component. And for the T2, we have here T2 sub X. And then we have T2 sub Y. Okay, for the weight, it's only the Y component. Of course, there's no X component. See? So this is the free body diagram. Let's try to erase this first so that we can move it later. Okay, so let's have this free body diagram of our force, which will be looking most of the time. Okay, so let's write all the given. So for our given, okay, so we have here the mass equal to 5.6 kilogram. Okay, theta 1 equal to 30 degrees. Okay, theta 2 equal to 45 degrees. And now we are asked to find the value of the tension 1 and tension 2. Okay, so we'll do a lot of mathematics here, but then it's basically just like component method. Okay, so let's just focus on the free body diagram. So what I usually do is I first write all the components. Okay, of course you have the X component, and the Y component. For our X component, as you can see, we have two X component. We have T1 sub X and then T2 sub X. Okay, for our Y component, we have here T1 sub Y, T2 sub Y, and then we have here the weight. Okay, so here. Now let's write the values of this, or of course we do not have the exact value, but we have our formulas for that. Okay, for us to solve for the T sub 1 sub X, that is X component, so that's cosine. So for you to solve this is T1 cosine of 30, right? So for T2 sub X, that's T2 cosine of 45 degrees, right? Next, we have T1 sub Y. So this one, it's the opposite side. So that will be T1 sine of 30. And then for our T2 sub Y, we have T2 sine of 45. And then for the weight, we have here G. But I forgot to add that you also have to consider the direction, which are the negative here. So we have T1 sub X is negative, okay, because it's towards west. Okay, T2 sub X is positive, okay, so T1 sub Y is positive because it's towards north. T2 sub Y is positive towards north, and weight is negative because it's towards south. Okay, so the next thing you have to do is to write the conditions for equilibrium. So the conditions for equilibrium, of course, number 1, so we can say that it is in equilibrium. So the object is not moving. It is still if the summation of forces is equal to 0. So if the summation of forces will be equal to 0, therefore the summation of forces along the X is equal to 0. Same thing with the summation of forces along the Y will be equal to 0. So here's the conditions, okay? So this 3. How will we use that? So let's have first the summation of forces is equal to 0. Along the X, the summation of forces along the X is equal to 0. So let's just add these two. Okay, for our x component, summation means add. So we will have here t sub 1 sub x plus t sub 2 sub x equal to 0. Then let's substitute the value. So t1 sub x is negative t1 cosine of 30 plus t2 sub x is t2 cosine of 45. This is equal to 0. See? Again, we just substituted here the value t1 sub x is this one. t2 sub x is this one. So, t2 cosine of 45. Okay? So, to simplify this, we can add t1 cosine theta on both sides, or we can just transpose it to the other side of the equation. So, that will be t2 cosine of 45 is equal to, this negative will become positive, t1 cosine of 30. Right? So, for us to have the value of t2, we will divide both sides by by cosine 45. Cosine 45. Cosine 45. So, we can now cancel out cosine 45 here. So, t2 is now equal to t1 cosine of 30 all over cosine of 45. Okay, so let's just stop here for a while because we do not have value for t1. Okay, again, that's t2. Okay, next, let's now have, we're done with this. Okay, let's now use this one, the summation of forces along the y. Okay, let's move here. So, the summation of forces along the y is equal to 0. So, therefore, the summation of forces along the y are the following. T1 sub y plus T2 sub y plus weight is equal to 0. How did we get that? So, here, oops. Again, for the y component, so you just add all the y components. Okay, kasi the summation of forces along the y. So we just add here. So let's borrow this one here below. Okay, let's substitute the value. Okay, substitute the value. T1 sub y is, oops. T1 sub y is positive t1 sine of 30 plus t2 sub y is t2 sine of 45. Weight is equal to negative mg, so that's minus mg equal to 0. So for us to have the value here, we can move this, okay? So this will be positive mg. So we have now t1 sine of 30 plus t2 sine of 45, right? So for us to solve this, we need only one variable. Of course, it's hard to deal with two variables, okay? So we have to make here the same variable. So we can substitute here. So again, listen. So here, the T2, the value of the T2, okay, we'll substitute here the T2 that we have solved a while ago. So let's go back to our solution. This one is the value of your T2. Here, let's paste it here. So a while ago, using the x component, okay, the summation of the x component, we were able to arrive with this equation. Now, we'll be using this, okay, so that, okay, we'll substitute it here so that we can only have one variable, which is t1. So, let's substitute this. So, here, let's just copy this one. This is t1, oops. T1 sine of 30 plus, again, substitute that. So that will be T1 cosine of 30 over cosine of 45. Okay, and then we still have here sine of 45, right? We just substitute again T2. Okay, this T2, the value of this, which is an equation, to this, so that we can have T1 and we can add these variables. Equal to mg, so m, that is 5.6 kilogram from your given, multiplied of course with the acceleration due to gravity, 9.8 meter per second squared. Okay, so we can solve for the value of this, and this will be 54.88. 54.88 Newton. So that's kilogram meter per second squared, so Newton. Now this one, you can use your calculator. But class, you have to know that you have to give me here 3 or 4 decimal places. Okay, so that the final answer will not have a very big discrepancy. Okay, so the level of uncertainty will be decreased. Okay, so again, T1, let's use calculator. Okay, so sine of 30 is 0.5. So 3 decimal places, so that will be 0.500 plus another T1 equal to, let's use again the calculator. So let's have here, of course, that will be cosine of 30 multiplied by sine of 45 all over cosine of 45. So let's get 3 decimal places as well. So that will be equal to 0.8660 or 8.66. Okay, so you see that? Okay, now we can add this too. Okay, let's add using our calculator force. Anyway, this is my phone. Okay, so oops, that should be 0.500 plus 0.866. Okay, so that will be, of course, let's write it, T1 multiplied by 1.366. Of course, there's no unit because we just have the cosines and the sines of those number, 0.88 Newton. Okay, so for us to get the value of T1, we divide both sides by 1.366. 1.366. Okay, so cancel. We have now T1 is equal to, let's see. Okay, so that will be 54.88 divided by 1.36. So that is 40.18. Okay, 40.17 or 40 point, that's 17.5. Siguro it will be safe if you write the normal answer. Okay, so that is 6. So if you will write the normal answer, of course you do not have to round it off, but for the final answer, let's express it in 2 decimal places. So that will be 40.18 Newton. So let's box this. This is the value of your T1. Okay, so now what is the value of the T2? We'll go back to our solution. Okay, let's see our solution. So for us to compute for T2, we can now just use this. Okay, let's just substitute the value, but anyway, we have the value of T1. Now, using the value of T1, we can substitute here. Okay, use this first. So this will be equal to, okay, that's your 40.18 Newton multiplied by cosine of 30 over cosine of 45. So T2 will be equal to, so let's use our calculator. That will be 40.18 multiplied by cosine of 30 all over cosine of 45. This gives us 49.9695. So let's just write that. So that is 49.9695 Newton. Okay. And two decimal places for the final answer. So T2 is equal to 49.97 Newton. Okay, let's check if, oops, I think we should have here 18 instead of 8. So there should be another 1. Okay, so that will be equal to 49.21. Sorry, I miswritten that. So it should be 49 again. That should be 40.18. A while ago, I just typed here 40. So let's delete this one again. It should be 40.18. So if it's 40.18 multiplied by cosine of 30 all over cosine of 45, T2 is equal to 49.2102 Newton, or T2 is 49.21 Newton. So let's box this one. This is the value of your T2. Okay. So going back to our equation, so let's recall, okay, what we have done. Okay. So we first use, okay, here, the summation of forces along the x. So that's T1 sub x plus T2 sub x equal to 0. Then substitute, and then because this is negative, we just transpose it on the other side. Or we can say that we add T1 cosine 30 on both sides of the equation. So we're able to get this. T2 is equal to T1 cosine 30 over cosine 45. Next, we add all the y component, and the y component are T1 sub y, T2 sub y, and weight. Okay, and then we solve this. Then we substitute here T2. Okay, so this is T2 here. Let's copy this one here, there. Okay, so we substitute this value of T2 to this in our equation so that we will have one variable, which is T1. So we can add this. Okay, then that. Okay, so for you to check, you can use any of the equation that you were able to make. If, for example, you can use this, substitute the value if they will be equal, or if this will be. Okay, so for me to check that, I would like to use this equation. This one. Let's see. Let's try to check it. Here, below. So for checking, okay, checking is, of course, is an option. But then, of course, it would be nice to check your answer. Okay, let's substitute the values that we have, and then let's see if it will be equal to this. Okay, of course, mass is 5.6 kilograms multiplied by 9.8 meter per second squared. Okay, the value of our T1, let's now substitute here. What is T1? 40.18. 40.18 sine of 30 plus the value of our T2 is 49.21 sine of 45. Let's see if they will be equal. Let's use our calculator again. So let's have first the weight. 5.6 times 9.8, and that is 54.88. So 54.88 newtons. Okay. Next, let's have here the other side of the equation. So that will be 40.18 multiplied by sine of 30 plus 49.21 multiplied by sine of 45. And the answer is also 54.88. But that's, again, that is, oops, sorry. But that is 54.88 or approximately 89. But it's almost the same. So that's 88 Newton. And because these are the same, then meaning you got the correct answer. Okay, so again, that's how you compute. I'll have another video for another example. Okay, thank you.